Hello class and welcome back to our second online learning lecture. Today we're going to be covering shark characteristics, continue what we learned from last week. We're going to go over form and function of sharks and finally discuss a few different types of sharks today. So going off with what we learned last week, let's discuss a few things and review a bit of the things that we covered last week. We discussed that some sharks could be homoeothermic and some sharks can have warmer blood than the water around them. We discussed the lateral line, which is a line of pores down the side of the shark, and it's used to hear and feel pressure around them and feel where things are coming from. We learned about ram ventilation, so sharks have to continually move forward so that they can move that oxygenated water over their gills. We discussed the ampullae of Lorenzini, so these organs can detect weak electrical fields that are emitted by their prey in their muscular movements and in their heartbeat. These are small pores on their head, and they lead to chambers lined with hair cells, which are connected to tubes filled with conductive jelly. Their teeth, they have a constant supply of new teeth that are moving forward to replace worn and damaged teeth, and some have crushing plates, some have serrated teeth, and others have needle-like teeth. Sharks have nares that they use to smell with. They have two openings, and as a shark swims, it pushes water across their olfactory senses, that's their smelling senses, and they smell very well. They have a nictitating membrane. Sharks have this when they're attacking their prey. They have ears, which they in fact have very good hearing. They lack external ears, but they have two small holes in the top of their head, and these openings are thought to transmit sound and pressure waves down the hearing organs. And they are also very fast. Sharks, such as the mako, are very quick. One other unique characteristic about sharks is that they have a spiral valve. A spiral valve is in the lower portion of the intestines of some sharks, skates, and rays. It's a modification of the ileum. So in mammals, they have very long intestines, whereas sharks have very short but very twisted, coiled intestines, and so this increases their surface area of the intestine. So inside you can see that spiral organ, and it increases nutrient absorption. So by keeping the material in the ileum for a longer period of time, they can pull out all the nutrients that they need, and so that's why they have to feed very infrequently. They don't have to feed very often, and so it passes through this short colon and it almost becomes fully digested. We discussed the ampullae of Lorenzini, and so they provide sharks and rays with a sixth sense capable of detecting electromagnetic fields. I do need to make a correction of last time. I think I said they were discovered by Lorenzo Lorenzini. It is in fact Stefan Lorenzini, and I think I said the 1600s. It is in fact the 1700s. Alright, so we're going to learn a little bit about gills. This is more when we're going to be talking about bony fish, but it's important to cover it now because we're discussing sharks. So this is a gill structure right here on the left, and the first thing we're going to discuss is kind of the support of it, which is the gill arch. So the gill arch supports the gill rakers and the gill filaments, and that's this portion right here. So the gill filaments are blood-filled, oxygen in, and CO2 and other wastes go out. So these pink structures here are the gill filaments. This is where oxygen exchange occurs. So the surface area of the filaments is about 10 times the surface area of the fish. This is so that oxygen can be exchanged. Gill rakers are used to keep big stuff off the gills, and they are enlarged in filter feeders. So these, in a filter feeding fish or in a filter feeding shark, you'll have these elongated. So which one is more likely to be a filter feeder, the one on the left or the one on the right? And if you said the one on the left, you are right. These are enlarged, and these can basically filter out krill and small plankton. Alright, so here, which ones are the filaments? Is it A, B, or C? If you said A, that's correct. These are the filaments. This is where oxygen gets exchanged. Which ones are the gill arch? Here, A, B, or C? And if you said here, B, these are the gill arch. And finally, which ones are the rakers? A, B, or C? And if you said these right here, C, you are correct. Alright, so we're going to get into the shark tail's form and function. So here in this picture you can see one of my favorite sharks, the thresher shark down here in the bottom, and you can see all the different shark names next to their different types of tail. You have the nurse shark, tiger shark, porbeagle, thresher, which is this one right here, the cookie cutter, and great white. But first let's go over some prefixes for tails. You have iso, hetero, homo, and circle. Iso meaning equal, hetero meaning different, homo meaning same, and circle meaning tailed. So homo circle means same on the top as on the bottom. Both lobes are the same sizes. You can see here where a homo circle is the same and hetero is different. Homo circle tails are going to provide for forward thrust, and hetero circle is going to be forward and lift. So homo circle pushes forward, whereas hetero circle is different on the top and the bottom. So it provides forward and lift. So let's talk about a few different sharks that we'll be learning in this class. So the tiger shark, the tail of the tiger shark is pronouncedly epicircle. So the upper lobe is longer and heavier than the lower lobe. Movement is controlled by swinging the body from side to side. The larger upper lobe delivers a maximum amount of power for slow cruising or sudden bursts of speed. The tiger shark has a varied diet, and because of this, it must be able to twist and turn in the water easily when hunting turtles, fish, stingrays, and other sharks. And here's that picture of a tiger shark, and you can see a diver right in front of him. The nurse shark. The nurse shark is common in shallow waters around the tropical coast of America and Africa, and is nocturnal. Its prey consists mainly of invertebrates such as crabs, lobsters, sea urchins, and octopus. This causes the sharks to spend most of their time on the seabed. As a result, high acceleration is not necessary, and the lower lobe has almost completely disappeared. They swim with an eel-like motion using broad sweeps of their elongated tails and cruise slowly. Here's a nurse shark. Notice the barbels on this nurse shark and the tail. The porbeagle. The porbeagle is a heavily built pelagic shark closely related to the mako and great white, which hunts on schooling fish such as mackerel, herring. The tail is used for propulsion rather than having to swing their body from side to side. The large lower lobe provides greater speed to help them keep pace with their fast-swimming prey, and their lateral keels may reduce drag, making it more efficient hunting. So the lateral keel is this right here on the side. Another one of my favorite sharks. So this is just a miniature great white, a little bit smaller than a great white, maybe 3 to 4 feet, and very quick. Another of my favorites is a thresher shark. The thresher is found in tropical and temperate waters around the world and feed on fish and squid, which they are believed to herd, then stun with their powerful and elongated upper lobes. The 3 species of thresher are active and strong swimming sharks. The evolution of the highly elongated tail, which may be half of their total length, has not been at the expense of speed or agility. And here's a thresher shark. You can see how long its tail is. The great white. The great white is primarily a coastal and offshore species, but can be found far from land. Its body and tail have a shape similar to that of a tuna. Its upper and lower lobes are of almost equal size. This provides for both slow cruising and fast chasing speeds. And here's the tail down here. Here's a picture of the great white. Lastly, we have the cookie cutter shark. The cookie cutter shark hunts squid and crustaceans, but will attach itself to larger fish or dolphins with its strong suction lips. Using its scoop-shaped lower jaw, it will then cut out a conical plug of flesh. Its tail has broad lower and upper lobes of similar shape, which are luminescent and may help to lure prey towards the shark. And here's a little diagram of the cookie cutter shark. Here's the cookie monster saying C is for cookie cutter shark. All right, one thing that I wanted to discuss before we finished up today was shark finning. So shark finning is a practice that has been going on, and unfortunately it's still going on. I wanted to show this really good video on why sharks are so important, and it kind of basically lays down how shark fins are used and why it's so terrible. So if you guys would just watch with me.
Biodiversity is really how we define our own existence, isn't it? It's us and, say, tens of billions of other species that occupy this planet with us.
It's like there's this incredible web where we're all connected. And we start to lose these linchpin species. The environment starts to fail.
When we translate human activity into these forces of extinction, there's several major factors that are contributing.
One of the major drivers of extinction is that we hunt some species to oblivion. It's what we do with sharks now.
With the explosion of demand for shark fin soup, global estimates for the shark fin trade put it in the neighborhood of $1 billion. It's a huge amount of money. So sharks are targeted by fleets around the world.
They may simply cut the fins off and then release them to a slow and very unpleasant death.
You keep all the sharks or put the bodies back? So you cut the fin and put.
We don't actually know how many sharks are in the ocean. What we do know is that the big sharks, the apex predator in the open ocean food chain, their numbers have declined between 90 and 99%.
Sharks have survived 4 mass extinction events. They've been around the planet longer than dinosaurs. A lot longer.
Sharks have ruled our oceans for over 400 million years. They have been responsible for regulating and maintaining the entire balance across our oceans. Now we're in a situation where sharks are being removed from that system.
Humans are really the single most impactful species this planet has ever seen.
We have these prehistoric brains and we have this godlike technology, and when we bring them together, the result is not necessarily a happy one.
You know, species are like a house of cards. You can't just sort of take one card out of the deck and not expect the deck to crumble.
All right, so really great organization, OPS. I am actually going to be attaching a link of a documentary that they made, and I hope you guys watch it. But for now, let's go ahead and quickly run through some of the different sharks that we covered just now, and the ones that I'll be wanting you guys to know for this class. So the first one is the great white, the blacktip reef shark, the bull shark, the mako, tiger, thresher, notice the long tail, the whale shark, and cookie cutter shark. Alright, so we're going to end this online learning lecture with a few reminders. So first off, I want to thank you guys for learning with me today. I want you guys to try to keep an eye out for Google Classroom posts. I am going to be putting up supplemental material for everything that we've covered. So live session next week may be through Zoom, so we can play a shark review game. I really need you all to participate. I am going to be rolling out some information for a new software that we're going to be using called Edgenuity. If some of you have already had teachers approach you about this, this is a school-wide initiative to try to get everyone on one software. Racing Extinction is going to be the link of the documentary that I want you guys to watch. And lastly, stay safe, and I hope you guys can learn with me next week.